This is section 4.2, proving triangles congruent. We know what congruent triangles are. We just saw that in the last section. Congruent triangles are triangles in which you have three pairs of corresponding sides congruent and three pairs of corresponding angles congruent. So in the two triangles I have drawn here, I've marked that I have three pairs of sides congruent. Here's one pair that I've marked with one dash. The second pair I've marked with two dashes. And a third pair I've marked with three dashes. That's showing that I have three pairs of corresponding sides congruent. I also have three pairs of corresponding angles congruent, and I've marked those with one arc, two arcs, and three arcs. So I have three pairs of corresponding angles congruent. So I can say, by the definition of congruent triangles, that triangle ABC is congruent to triangle. And now the order in which I label the second triangle depends upon the order in which I labeled the first one. I have to label it in the same order so that the angle that corresponds with A goes first. So X corresponds with A. The angle that corresponds with B goes next. And the angle that corresponds with Z goes third. That way, just by reading this statement right here, I know exactly what corresponds with what angles correspond with each other and what segments correspond with each other. So I always label congruent triangles in the same order so that they correspond. So that's really 6 things that the definition of congruent triangles would require to show that they're congruent. 3 pairs of angles, 3 pairs of sides. 6 things. That's a lot to show in order to show that 2 triangles are congruent. And if I could, I would want to shorten that list down from 6. And so I asked the question, how do we prove that 2 triangles are congruent? What is the minimum amount of information that we need in order to know that 2 triangles are congruent? Do we have to show all 6 of these pairs every time? 3 pairs of angles and 3 pairs of sides. And it turns out we don't need to show those, all of them. And the minimum, in most cases, is 3 things. So we have this first postulate. We're going to have 3 postulates here. Postulate, remember, is something we assume to be true without proof. The first postulate is called the SSS postulate, or side, side, side. S always stands for side in this case. It says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. All we need, instead of showing all 3 pairs of sides are congruent and all 3 pairs of angles are congruent, this postulate says we can forget about the angles as long as we know 3 pairs of sides are congruent. So if I know, on the triangles I've drawn here, if I know that AB is congruent to FG, and I know BC is congruent to GH, and I know AC is congruent to FH, I've got 3 sides of one triangle congruent to 3 sides of another triangle, then this postulate says the triangles are congruent. So I can write triangle ABC is congruent to triangle. F corresponds with A, so I write that first. G corresponds with B, and H corresponds with C. The triangle ABC is congruent to triangle FGH. And I don't have to check the angles. I now know that they're congruent, and by the fact that they're congruent, I know the angles are also congruent. But to show that those triangles were congruent, all I needed to know was that 3 pairs of sides were congruent. A little detour. Sometimes it's helpful to describe the parts of a triangle in terms of their relative positions. So with this triangle I've drawn here, we can say side AB is opposite angle C, because it's on the opposite side of the triangle. Pretty simple. AB is opposite angle C. We could also say side AB is included between angle A and angle B, because side AB right here lies between angle A and angle B. So if we use the phrase included for a side, it means it's between those two angles. Similarly, we can say angle A is opposite side or segment BC. It's on the opposite side of the triangle. And we can say angle A is included between which two sides? Side AC and side AB, or segment AC and segment AB. It lies between the two. Those two sides of the triangle form that angle. So using that language, we have a second postulate. It says, it's called SAS for side angle side. It says if two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the triangles are congruent. So the first postulate we had said if we have all three sides corresponding to each other and congruent, then the triangles are congruent. This one says we don't need to know all three sides if we know two sides and the angle included by those two sides. So the angle that those two sides create, the angle between those two sides. If we know those are congruent, then we know the whole triangles are congruent. So for instance, on these triangles I've drawn here, if we know that, say, EM is congruent to AO, and we know EL is congruent to KO, what else do we need by this postulate to show that these triangles are congruent? We have two pairs of sides. We need the angle that is included in those sides. So the angle included by EM and EL is angle E. The angle included by AO and OK is angle O. So if we know that information, two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then we know the triangles are congruent. So we can say triangle ELM is congruent to triangle, what corresponds with E? Point O. What corresponds with L? Point K. And what corresponds with M? Point A. We can say triangle ELM is congruent to triangle OKA. Now that's two ways that we can show that triangles are congruent without having to show all six pairs of things. If we have all three sides are congruent, we've got it. If we have two sides and the angle included by those sides are congruent, we've got congruent triangles. Third way, instead of side angle side, this is angle side angle, ASA. Angle side angle postulate says if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. Almost exactly the same as the postulate we just looked at, side angle side, except it swaps the word sides for the word angles and the word angle for the word side. So, on the triangles I've drawn here, if we know angle N is congruent to angle Y, and angle, say, M is congruent to angle K, what else do we need for this postulate to be applicable? We need the side that's included by those angles. Side included by N and M is side NM. Side included by angle Y and angle K is side KY. So if we know that information, angle N is congruent to angle Y, angle M is congruent to angle K, and side NM is congruent to side KY, then we know these triangles are congruent, and we can say triangle NMO is congruent to triangle. What corresponds with N? That's Y. What corresponds with M? That's K. And what corresponds with O? That's E. Triangle NMO is congruent to triangle YKE. Because we have two angles in the included side of one triangle congruent to two angles in the included side of the other triangle. Two quick examples so you can get a handle for how this is applied to problems. Do we know that the triangles are congruent? So in the first picture on the left there, there's two triangles that share a side. They share side BD. If they share that side, that means that side is congruent in each triangle because it's the same, literally the same side. So it has to be congruent to itself. That's an application of the reflexive property. Segment BD is congruent to itself. So it's used by both triangles and it corresponds to itself in both triangles. We also know AD is congruent to BC, and we know AB is congruent to DC. So we have really three pairs of congruent sides where BD is congruent to itself in the middle there. So, does three pairs of congruent sides give us congruent triangles? It does. And we can say triangle ABD is congruent to triangle. It corresponds with A. It looks like it's C. It corresponds with B. It's going to be D in this triangle on the right. And it corresponds with the role of D in the triangle on the left. That's point B in the triangle on the right. The triangle ABD is congruent to triangle CDB. And we can check that with the sides. We know AD needs to correspond with BC. So AD corresponds with BC. Those are good. AB needs to correspond with CD. There's AB, there's CD, those match up. And we know BD needs to correspond with itself. Well, there's BD, and there's DB, which is the same as BD. So we've labeled them correctly. The sides and the angles all correspond with each other the way that we've written them. Alright, now about the picture on the right. Are those triangles congruent? Well, we have EF is congruent to HI, FG is congruent to IJ, and angle G is congruent to angle J. Does that make them congruent if we know that two of these sides and this third and this angle down here are congruent? Well, it's not side, side, side. We don't have the third sides congruent. It's not side, angle, side because we don't have the included angle congruent. We don't have the angle between these two sides congruent. And it's not angle, side, angle because we only have one pair of angles congruent, so it can't be angle, side, angle. That requires two pairs of angles congruent. So it turns out we do not know that these are congruent. So no, we don't know. We would need more information in order to know for sure that they were congruent. Even though the way I drew them, they look congruent, we don't know. It's possible we could have triangles that share two pairs of sides and that angle that's not included and still not be congruent. Here are your immediate practice problems. You're asked, are any triangles congruent in these pictures? If so, which ones and why? So two separate problems. Problem number one on the left, problem number two on the right. So in problem number one, look at those two triangles. See if you can tell that they are congruent. If so, name them and label them correctly. And tell me whether it's side, 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 SSS, side, angle, side, SAS, or angle, side, angle, ASA that tells you they're congruent. And in picture number two on the right, can you tell that those triangles are congruent? If so, tell me what they are and label them correctly, and tell me if it's side, 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 angle, side, or angle, side, angle, SSS, SAS, or ASA. That is the end of section 4.2.